Chris Matteson from Union AI is going to talk about their solution to solving this gap that exists between experimentation and production for GenAI solutions. You heard earlier that something like 95% of GenAI products don't actually make it to production and deliver business value. Chris is going to help you fix that. Chris.
Thank you so much, Miles. I really appreciate the introduction. And thank you all for coming here. I'm excited that everyone else is as passionate about this topic as I am and wants to listen to me and hopefully hear something, some useful nuggets of wisdom here that you can glean out of whatever I mumble on about. So, a way of introduction, so I want to give a little bit of the background to explain like how I got here. And I think that's going to explain partially why I'm passionate about this problem and really this gap here, that how much it resonated with me when that MIT study came out recently. So it was January 2015. I started working in automation, which is, I worked at a company called Puppet that did infrastructure as code. I actually just ran into my boss who hired me there like 30 minutes ago, and somewhere, Jeremy Adams is somewhere in here, I think. Which is kind of cool how this small world, everything loops back around. But I'm reticent to call this automation at that time. Like, there's no AI in there. There's none of this, the models that we think about today. Like, this is literally was just stepwise documenting the steps you would take, a human would have stepped through for infrastructure, and then we turned that into code, and then a system ran that. Right? Cool. Not what we would think about as automation today. After that, I was an early employee at HashiCorp and kind of did that ride. Very similar thing. Infrastructure as code, tools that help to do security, automate some of these processes, but very much traditional software, automating things that previously were more brittle and human. After that, I went on a bit for a couple different companies. I ended up at a place called Fermyon, where I did serverless WebAssembly. So I started in Fermyon in January 2023. ChatGPT had just come out 2 months, not even before I started there. And so we're doing serverless WebAssembly. It's pretty unrelated to this task. It's about time slicing CPUs to do that really efficiently so I can jam a whole bunch of stuff onto a server. Well, as ChatGPT's buzz keeps rising, and then in, I think, February, Meta released their first version of Llama, and we look at open models, and it's like, it's not just OpenAI who could host and do this inferencing. You can do it too. That, of course, got the CEO of my company thinking. And he comes to see me and Chris, and he says, Chris, we should do something with AI. Okay, how many people had their CEO come to them and say, we should do something with AI? Yeah, I got that back in the beginning of 2023. I was like, this is dumb. This is real dumb. And what he wanted to do was, he was like, we're going to build a chatbot. And at the time, that wasn't completely old hat. People were still like, it's cool, I can build a chatbot for these things. But I pushed back, and I was like, if we're going to do something, like, we are infrastructure. If we're going to do something, we should do something that isn't just like this one-off like show we did it. We should see if there's a unique way that we add value to this ecosystem so that we can drive forward what people do in AI. And so we took our stuff for time slicing CPUs, we did it on GPUs, and suddenly in August of 2023, we're launching an inferencing engine for for doing inferencing with Llama 2. And I look at the conferences around here, and I'm like, oh, hey, there's this AI conference that's just starting. That's this tiny little one. It was over here at the UCSF Medical, I think. It's much, much smaller. The entire conference could have fit in this room right here at the time. And I'm like, let's go find out if people care about this. I learned a few lessons from that. One, people did really care about that. And I think we see here there's a ton of people doing inferencing. And Bedrock and all those kind of came out later to do that. It became clear they wanted custom models. And it also became clear it wasn't the right way for Fermyon as a company to go. So we didn't pursue that for us, but it's clear that there's a lot that people cared about on inferencing and be able to inference with their own models. So walk back, spend a couple years more on WebAssembly, and then I decided to start my own thing, which means I want to go take my own machine learning-based product and take it to market. It's part of the reason we're in this talk today now. So I ended up building this thing called ILID. Essentially, if you've got a food allergen, you can read labels on boxes in the grocery store forever. It takes a ton of time. Instead, tell us what you care about. You don't. Hold your phone up, it'll scan the entire shelf at once and put boxes around things. I'll say, cool, you said you're gluten intolerant? Don't even pick these boxes up, waste your time. These 3 are good, like could be good for you, and here's like the online review. So try to do, like recognize and add data very quickly. A lot of this was the traditional ML, but I needed the generative AI in order to help me build some of these pipelines to get this in here. And then I was also using generative AI to answer questions about things, to say, like, if I'm taking this to the hardware store, which one of these fertilizers right from my tangerine tree, right? Cool questions that people care about, they want answers to. But what I really needed to make this whole thing work was I needed vision models that would accurately recognize the products every single time. And what I quickly found out is I could get most of the way there, but I couldn't quite get to production. I've got using some stuff Apple had for AR image tracking. I got a real quick demo out. Took me no time at all. Thanks, ChatGPT helped me write that in the first place. And then I ended up getting this quagmire of pulling data, creating models, running training on my YOLO, my clip, and just doing this over and over and over. And I was doing it manually in Google Colab. And I just could never get it to the stage where I felt like I could actually give this to somebody because I couldn't use it in 2/3 of the grocery store, which meant that it was largely not that helpful. And so as I kind of wound that down, I was like, I need to go find another job. I was like, I really care about this area, and I passionately feel this problem of what does it take to get these things into production. And that's really where I ended up at Union. So the elevator pitch of Union is we have an open source tool called Flight. It is a orchestration tool that came out of Lyft, which is why we spell it weird with a Y. And so the idea is that if you have complicated workflows like we often do in machine learning, like I'm going to pull a bunch of data in, change that data, run a training model or training across a bunch of different GPUs, and then I'm going to have an artifact, I'm going to validate that artifact, and I'm going to do this all again in 2 weeks when I have new data. That kind of brittle workflow, they were doing 1,000 of those at Lyft all at the same time, and they were constantly breaking, they're constantly having to retry stuff. Things weren't working, they weren't effectively using GPUs they had, so they built Flight to solve that challenge. So today we now solve that challenge with Union, which is a paid version of Flight for both machine learning and for AI agents for orchestrating things like multiple agent calls and tool calls and all that. 4,000 companies use us, right? Pretty much every self-driving car company, LinkedIn, Spotify are all like users of our tools. So if you're trying to go buy GPUs to do your machine learning, that's what Union and Flight are for. But what we really do where we move people to success and in production is being able to orchestrate all of the steps you need to do so you can move faster. So now to like through the intro and to what I consider really the beginning. Who here expected me to give them the magic bullet today? This is going to solve all your problems and you're going to production. Good. Keep your hands down, because if you thought that, you should leave. I don't have that. Absolutely, like we don't know today what the right answer is, right? We have papers being released every single day, multiple times a day, about RAG is a thing, RAG is dead, now it's MCP, now there's this different types of model, and that different type of model, like we're using the state-based model, all of these different things that we think increasingly move the needle a little bit forward, but it just doesn't seem like it's quite getting us where we need to be. And so failure stats, again, we already mentioned this MIT study. Again, we see this over and over again, example after example. People tried to get to production and they failed. They were unable to move the needle far enough in order to get where they were feeling comfortable, like I never felt comfortable with actually releasing this to people. This is the world we want to be in, right? You start on this side of the bridge over here in Marin, and then you say, like, let's go to San Francisco. We're going to cross the bridge. Boom, we're there. And the crazy part about this actually is in traditional software engineering, and like 10 years ago in 2015, for pretty much anything you could come up with, I could have told you what this path was here, right? There's QA that you're going to need some automated testing. We've got CI, we've got version control. We knew the tools. If you told me the scope and how it's going to scale, I could tell you the infrastructure. Like, is this a fit for something like Lambda? Does this a fit for something like Kubernetes? Like, I could have told you all these things and designed this bridge without really caring about your use case, as long as I know how it went together. We know that for software engineering because we've spent so many decades doing this, moving away from waterfall sort of paradigms to modern paradigms to go do this. But right now, this is what we're at. With LLMs, you deliver in 2 seconds. The LLM is delivering you this much of the bridge, which is honestly amazing. That's a lot of bridge to get very, very quickly. The problem is, unlike the people that were actually building this bridge, who had a finished blueprint and had done all the work here, you pretty much just given the bridge and no other instructions and told, build a bridge. And right now, right there, you can get between San Francisco and Marin on that bridge if you're willing to walk up all the way to the top of the tower and down across the cables. I don't know, how many people are willing to do that? Okay, daredevils, that's awesome. Most people that I know would rather drive the car across the bridge when it's completed, and right now, you're not driving across that bridge. So I want to think about this as the metaphor of, like, we've got this amazing huge chunk here, but now it's on us to figure out how we fill in the rest to get there. And so the next part of this, I kind of want to go through a thought experiment that I've had recently that I think kind of reframes how people have been thinking about this and how I try to talk to people about this, because they try to look at LLMs as they want LLMs to deliver them the whole bridge. And I think they're thinking about this the wrong way. So I really want to think about business problems, right? We have a business problem, and the business problem to me is the box. That's everything it takes to solve that problem. And that could be something like, say, doing your taxes. And so if the business problem is doing taxes, and I put a pretty smart, untrained human to go do that, they can read a bunch of documentation, they can read through the files, and they're going to do an okay job in a long time. For all of them have done our taxes without trying to do TurboTax or something like this, we've seen this. This is painful. But we can improve this. We can add into this business problem other things. And a lot of that can be just training the humans. And how important this is for us to go train that human. And that's not just like, let's send them to college or send them a certification and do all that. There's also like continual validation of this. If I have like a call center, we're constantly monitoring people's calls from our agents and then giving them feedback for improvement. There's a constant feedback cycle we can have here to improve this really smart thing that is all of you in this room that are humans, to improve them to be better at achieving this business problem. And now you're going to be better, you'll be faster, because you've got some of this training, and we're continually provide that. But we can make it even better than that, because it turns out a lot of us are pretty mediocre at math. I was a math major, but I like the math where it's all letters, like the actual just raw calculate and crunch stuff. That's not my jam. So give you a calculator, the results are gonna be way better. You're probably gonna even have time now to double check that your math is correct, versus before you probably wouldn't have. If you didn't have the calculator. So we're increasingly adding tools that solve the system. While a lot of it's still the human, we're now using the tools and education, these processes that we can bring in here that we can orchestrate in, actually help us through this. And then we can take it a next step further, right? We think about writing software. And then we can take this a lot further than the calculator. We're going to make in areas where we can make deterministic decision trees, it's pretty straightforward for us to go build software that's going to walk us through this whole process and get this done. And so that human now is going to do even better, right? Versus here, right? What this really was, so like this is back here is really you. And then really train person with calculator, like this is in the 90s, H&R Block used to train armies of people every year to go do simple taxes. And then they would send the more complicated taxes, part of the training would be the complicated taxes go to the people that know more, right? Now, the H&R Block has software, but also we can give that software to you, right? So now the untrained human with software can actually be as good or nearly as good for a lot of use cases as the trained person with a tool would have been, which is awesome evolution of what we've done that we can get there. And so but we still have a human being. The software can't do it itself. We need that person in there. We need a person to fill out the things that we know the software will never be able to predict, don't know edge cases, can't follow these things. It's not a deterministic, easy inputs, outs. And so now we've got this LLM, and people did this, of course, right out of the gate, as they said, let me do my taxes with an LLM, and it did, again, okay. It's math, pretty meh. Sometimes, if it's not using a tool underneath the hood to actually calculate it, I wouldn't trust the numbers it's going to add up to. But you can actually get pretty far with an LLM just going at this to go do your taxes. But we've seen all of the places where this falls short and we don't get things done. And so we've started to build it with software, right? And that's what, as we've moved the needle further, we think about completing this bridge that we've been given the LLM, was able to do a lot of it by coming in here and adding software, and that's not just LLM, hey, use computer use and use TurboTax, right? This is where we're starting to add in all of these tools of, is this RAG, is this MCP, is this some context optimization, right? Is this my prompt optimization? All of these different tools that I've brought in here are helping to move the needle further and further where the LLM is getting closer to that nirvana that it needs to be at. But the problem is it's still not there. And I think this is the challenge, and this is the way I want people to really think about this, is this is the human in the loop, still having a person as part of this. This is the way that you get something to success today, is you still need to have a person doing the things a person does and letting software and LLMs do the things that they do well. But don't try to expect that the LLM, because it does things you never expected software to do, is going to do everything that the human is going to be able to do. We're not there in that stage today. If you want to go build something today, your best course of action is to still use LLMs where they work really well, right? There's an article that came out a month ago about Intuit, where the first version of Intuit, they tried to go build a AI into the system, and they built a chatbot that nobody liked and nobody used. And then they did proper product management, where they went and watched what people were doing, and they was like, oh, all these people are going over here and they're copying an invoice on one side into QuickBooks over here. That, from an email invoice to QuickBooks, we can automate that pretty well with an LLM. And that was really useful for people. So they're solving the business challenge of how do I do my accounting, still has human in it, but now some of that human piece is replaced with LLM where it's a good fit. So this is a very, very incomplete list. I would not care about this. Like, if you think about this is just, the point is there's so many things you can do today, and there's much more than what's here. All of this complexity means you need to deal with this in some way. Like, how do I tie all this stuff together? How do I make all this work to continue building my bridge? So that's where we come to the solution here, is orchestration. Complexity begs for orchestration. You need to be able to tie all of the pieces together so that that LLM who built most of the bridge can be tied to the context, the better context you have from optimized context and RAG, that you can make sure that you're optimizing your prompt and doing that in an automated way instead of just manually. I go in there and gut check that I'm like, I think this prompt response is better than that prompt response. So I would do that. Like, we need to add all these tools together, but because of that complexity, that slows people down on their way to production. And what we've seen going on now is this, if we are iterating manually on our prompts over time, our pace of change falls behind the change of the data, so we can never catch up and get things to production. To get it to production, we have to make sure that our change, the pace at which we can implement these new tools, that we can try these things out and get some validation, is faster than our data and our environment is changing. So we really think about with orchestration, and I'm not going to go through all of, there's a few demos here that I'll probably skip through parts of these things for the sake of time. But we think about what you need to do in order to wire all this stuff together. When you add complexity, I need to be able to see where logs are. I need to be able to debug. I need to know how they're tied together and that it's passing data. Because if I don't, then I'm spelunking through every different system. Right? And so here we show like if I have an error, how I can retry this. So a common use case, let's say like we've got a customer, they've got pulling in transit data for every city. The file for New York City, much larger than the file for Salt Lake City. But if they put enough memory in all these containers to manage for New York City every time, then they're going to be massively wasting their resources. Instead, with orchestration, I can go in here and I can say, hey, use a small amount of memory, do it. When it fails, retry. Exactly like a human would do if there was some failure that occurred. They're going to go in there, they're going to adjust the memory and retry. We can bake that into orchestration with the automation. Okay, shows that. And then on the fly, if I need to go through decision loops here, so this is the agent process, right? Let's go define a plan, and that plan's going to have a bunch of sub-agents, and then from there, we're going to actually go create it. So in this one, it's we're making peanut butter and jelly. I have an agent that gets jelly. I have an agent that gets peanut butter. I have an agent that gets bread, right? And I have an agent that makes the plan and decides what order we need to do this in. Because I can't spread the jelly, I can't spread the peanut butter before I go get it. So we need to go create that plan and wire it together, make sure each of these pieces are successful, and then we can go make the peanut butter and jelly sandwich. Scalable workflows, a lot of this stuff we need to fan out. And we need to do this in a way where we can go take advantage of resources. I have to go request resources right now, wait for that to and stand it up myself, and then go deploy stuff, or I deploy it sequentially and it takes forever, right? Again, I'm not getting to production quicker. I'm spending more of my time on DevOps and MLOps and less of my time on building my actual system. So we see here just an example of doing a classic training where we're removing a bunch of features through various iterations to figure out if we can, which of these features we actually need and which can we removed while still maintaining a very high efficiency rate with our model. So let's just go show the actual, yeah. So you can see all of the stuff that's going to run, and it's just going to start spinning off just a ton of workloads here over and over and over, looping through this, saving our engineers time of having to go do all this themselves. And then finally, the last one here is kind of brittle pipelines here. Again, if we're talking about things that can crash, that's a constant problem that we have. When we add more steps, things will break, and if we require a human being to recover it, we're going to move slower. So in this, we just built a example that automatically forces itself to crash, and you can see flight will actually automatically recover and continue from where it broke. Cool. And so try to get this done on time. Again, long-running workflows, this complexity is kind of our jam. So Union AI, we're end-to-end orchestration for machine learning. 4,000 companies are using us for that, and then for AI agents, so that everyone can build. We have people on production now building AI agents on top of us. You can use frameworks like LangChain, but you run on us, because if you need a hit, you keep hitting Anthropic, and then you get throttled by Anthropic, your system will fail unless you're capable of saying, oh, that was a failure, let me retry, let me back off and do this. You need to have that kind of capability built in there in order to manage this scalably. Spotify, like when they moved from their, for their machine learning, they moved from their stuff, their homegrown system to us. They deleted 2/3 of their code because what they were deleting was all the try catch, the caching, the wrapper code that you have to write in order to handle all of the failures and to be durable execution for this. Like we provide you that in the orchestration so that you can more quickly add all of these tools. And so right now, we have a beta, so we have V1 has been out. It's been out for years. Tons of companies using it. We have a beta of our V2. The nice thing about V2 is it's much, much faster. It's even more scalable, and it's pure Python. So before we were Python, but a subset of that. Now it's pure Python. If you've got some existing Python that you've already written to do your stuff, you add a couple decorators, and you are working on flight out of the gate. So we could just get people much quicker for a adoption scale, which again is going to move your people, your AI engineers and your ML engineers to success that much faster because we have sped them up from using something they know how to use, languages that they're used to, tools they're used to, and we just go and make that scalable so they don't have to think about the durability of that. So wrapping this all up, I've got a minute left. I'm happy to answer questions. I definitely left our CEO's LinkedIn here and didn't put in mine, so sorry about that. You can find me. I think the net that I want to leave you all with here, right, is You realize that LM's super powerful, but you have all of these other tools, and we don't know what the right combination of tools is going to be yet. But the one thing we do know for certain is it is a combination of tools, and we have to manage that complexity. So the better that we can manage the complexity, the better we can scale and move our applications forward faster and get things into production. Thank you. We have time for questions, or no? Wrapped. Cool. Thank you.